Third of 3 videos here, getting ready to start. We're in day 3 of our unit on similarity. We've been talking about how we can apply the idea of proportions to some different triangle things. We've talked about the triangle proportionality theorem. We've talked about its converse, how we can use it to check to see if we have a parallel line cutting through a triangle. So now the last thing we're going to talk about, kind of taking a different turn on things, a completely new idea. This is called the Triangle Angle Bisector Theorem. You should know what a bisector is. That means cuts in half, right? What is it cutting in half? Apparently an angle. Okay, so here's the big idea. It would be very simple for me to think that if I cut this angle in half, that these two sides, B to D and D to C, are equal to each other. And here's the one thing that I want you to remember from this video. That's not necessarily the case. Okay? BD is not necessarily equal to CD. Now, it could be, so maybe I shouldn't write that symbol in, but it's not necessarily equal to it. Instead, here's what we know, okay? And the reason, by the way, if you want me to draw a quick proof of that, watch this, okay? Here I go. Here I go. Let's make that triangle uneven, okay? Now look, if I cut this angle exactly in half, that would be that'd be about an 80 degree, it's a 100 degree angle, so if I cut it 50 degrees, that'd be about right here, almost done. Give me a second here. There. Those two angles are the same. Do you see it now? Right? That it's obviously, hey look, the distance from here to here is not the same as the distance from here to here. Okay? So I need you to keep that in mind. It doesn't mean that the opposite side is cut in half as well. But it does mean if we have these two sides, these two angles are equal, that means the ratio of BD to DC is the same as the ratio of AB to AC. I might be able to say it like this as well. Let me put some numbers in. If BD is 5 and this is 10, so notice not necessarily equal, right? Okay. Then if this is a 2, this is twice as long, 2 becomes twice as long. Okay? That's how that proportion works. Now let's go through and do a few examples. You probably had to pause, right? Go ahead and pause if you need to and write down this example and write down this over here. Okay? But we're going to be able to use this to solve some problems. Like such. Last example for the day. Find RV and VT. Okay, well what I notice here is that I have an angle bisector, right? Alright, let's go through and let's apply this idea then. By the way, you'll notice another way that I could have written this. Eventually what I'm going to do is I'm going to take BD times AC and AB times DC, right? Those the cross multiplication. If you don't like saying it like this, that this ratio to this, you could say, if you wanted to, I'm going to keep 2 and 5 on the same side of the fraction. 2 is to 5 as 4 is to 10, and you're going to get the same answer if you like that. So you could always say that AB is to BD as AC is to CD. Okay, that's the nice thing about it, because look, when I cross multiply this, I get AB times CD on one side, right? I get BD times AC on the other side. Well, look at my two statements here. AB times CD, BD times AC. So you end up with the same thing. In fact, I like this format better. Okay, you might go ahead and just pause and write that down for a second. But we're going to take that idea and apply it. Okay, so here's the idea. I know that if this angle is cut in half by a bisector, that the 10 is to the x plus 2, this 10 is to the x plus 2, as the 14 is to the 2x plus 1. So notice, as long as I'm saying the 10 and the 14 are both on top because they're the corresponding parts, the x plus 2 and the 2x plus 1 are the same spot, both on the bottom because they're the corresponding parts. And I'm saying over here that the 10 and the x plus 2 are on the same triangle, right? That's how I'm going to set this up. Now when I go ahead and cross multiply, I see some distributive property coming, so be careful about that. That means I have 10 times 2x plus 1 on one side. Oh, there's our bell. Okay, that means I cross multiply and I have this. I'm going to distribute out the 10 on this side. That would give me 20x's plus 10. On the right side, I have 14x plus 28. I'm going to subtract the 14x. That means 6x plus 10 is equal to 28. I'm going to subtract the 10. 6x is 18. That means x is equal to 3, right? So x is 3. That was not what the question was asking, though. The question said find RV and VT. So we got one last step, right? That means RV must have been 3 plus 2, 5. And VT is equal to 2 times 3, which is 6. And 6 plus 1 is 7. So we see they're not equal to each other, right? We even see it here. Now, if you could do all those problems, if those make sense, this one's probably the most confusing, this angle bisector thing. But if those problems make sense, then you're ready to come in and do the homework next time. You'll get a good chance to practice it while you're sitting in our classroom.